Welcome, ladies and gentlemen. So what I like to do is show you how to determine the vertices, the center, the co-vertices, as well as the foci of an ellipse. So basically in the last video, we did the exact same thing, except the center was at the origin 0, 0. So we already had that kind of knocked out of the way. In this example, though, we need to figure out what the center is. And I wrote in the center, and it's just like our videos for a circle. The center is going to be h comma k. Basically, whatever we're subtracting from our x and subtracting from our k are going to be our h and our k. Now, I don't really want to get too in depth with this, but again, if you haven't watched any of those previous videos, remember we can rewrite a subtraction problem as x minus -3, because remember it's x minus h, right? Well, x minus -3 is the same thing as x plus 3. So if you look at this, what are you subtracting from 3? It's x minus h, x minus -3. That means h is equal to -3. So in this example, we can say that the center is at the opposite of 3, which is -3, and the opposite of 1, which is -1. OK, so once we kind of knock out the center, the next thing we want to do is figure out our a, b, and c. Remember, the a represents, or actually I wrote in what a represents, b represents, and c represents. Remember, a is the distance from the center to your vertices, which represent your major axis, or your vertices are the endpoints of your major axis. Remember, the major axis is always larger than your minor axis. So therefore, a squared is always going to be larger than b squared, because b remembers the distance from the center to your co-vertices, and the co-vertices are the endpoints of your minor axis. Major axis is always larger than minor axis. A is the distance from the center of the vertices, b is the distance from the center of the co-vertices. Therefore, a is always going to be larger than b for an ellipse. So we have, if you look at your a squared and your b squared as your denominators, so we have two. We just need to decide which one's a squared, which one's b squared. Well, remember, a squared is always larger than b squared. So therefore, I can make the determination that a squared is equal to 9 and b squared is equal to 4. Excuse me. OK. So therefore, a is equal to 3 and b is equal to 2. Now, again, to be able to determine what c squared is, we can use the relationship. So I can say that c squared is equal to a squared minus b squared. So c squared is equal to 9 minus 4. C squared is equal to 5. Take the square root on both sides. C is equal to the square root of 5. Now, a lot of times it kind of makes sense of this. Again, we need to plot the information. This is the exact same thing I did for when our center was at 0, 0. Actually, you know what? Let me write this in red so we can differentiate all the information. So I'll just write center is at -3, -1. OK. So we have a center at -3, -1. So I'm going to go -3, 1, 2, 3, down 1. All right. Now, I prefer to plot the information rather than doing some formulas that kind of make sense, because once I can plot the information, I can determine where everything is at. Or I can determine what those values are that I'm going to write down. Now remember, a squared was 9, right? Because a squared was always larger than b squared. If a squared is under the x, that means my major axis is horizontal. So a lot of times what I like to do is I write in just my major axis. I write it as a nice dotted line, and I just write down major axis. This lets me not forget that the major axis is horizontal. And that's very important, because not only do the vertices lie on the major axis, the foci lie on the major axis. And the co-vertices lie on the minor axis, which is perpendicular to the major axis. And they intersect at the center. So even though these are not really a part of the graph, I'm not really graphing them. I'm just plotting the information so I know where it is. So I'm just going to plot in the minor axis, which is perpendicular to the major axis. OK. So to find my vertices, the distance from the vertice to the center is a, which in this case is 3. So I go to my center, and I say, all right, it needs to go along the major axis 3 units to the right and 3 units to the left, because remember, an ellipse has endpoints to the left and to the right. So what I'm going to do is from this point, I'm just going to go to the right 3 units, 1, 2, 3, and to the left 3 units, 1, 2, 3. OK, you can see me. Good. Now I basically just plot what are actually, let's do everything. I'll go ahead and label those as my vertices. Now I'm going to do, following that long same path, I'm going to do my co-vertices, which is the square root of 5. Now, we know that 2 squared is 4 and 3 squared is 9. So square root of 5 is going to be somewhere between 2 and 3. So I'm just going to approximate. So I'm going to go over 2 dash point something, over 2 point something, and say that's my foci, and that's my foci. Now to find my co-vertices, that's going to be the value of b from the center, which in this case is 2. So from my center, I'm going to go up 2, and I'm going to go down 2. And I'll label those points, co-vertice and co-vertice. I think it's much easier to kind of visualize where the points are and then write the coordinate points rather than using the formulas that sometimes you'll find in a textbook or that your teacher will give to you, which I used to do as well. But I think it's just easier just to visualize everything and then write down the points. All right, so my vertices, again, from the center are 3 units left and right because the major axis is horizontal. So my vertices end up giving me, 0, comma, negative 1. And it looks like 1, 2, 3, 4, 5, 6, negative 6, comma, negative 1. My foci are along that same axis. Now, here's where it kind of gets a little difficult because we know that my vertices are going left and right from negative 3. So from negative 3, I'm going to add square root of 5, and I'm going to subtract square root of 5. Well, that's what I basically did here. From negative 3, I added 3, which gave me 0. And from negative 3, I subtracted 3, which gave me negative 6, right? So that was easy to do. But what are you going to do with the square root of 5? You can't take the square root of 5 and add it to negative 3. So I'm just going to leave that as plus or minus the square root of 5, comma, negative 1, because the y-coordinate still is the same. And then lastly, my co-vertices, those are going to be up and down. So therefore, the x-coordinate of my center remains the same. But from negative 1, I'm going to go up 2, and I'm going to go down 2. So therefore, that's going to be negative 3, positive 1, and negative 3, negative 3. OK, there we go. In this next example, a lot of students will get kind of stuck on this because we won't have a denominator for 1. And they'll kind of say, you know, what do we do now? Well, again, we want to make sure it's written in this format, so let's write it into that format. If we don't have a denominator explicitly written, then we know that that denominator is going to be 1. Now, our two denominators are 3 and 1. Remember, those represent a squared and represent b squared. Remember, a squared is always larger than b squared. So therefore, we can say a squared is equal to 3 and b squared is equal to 1. So yeah, let's use green. I kind of like that idea. All right, so I'm going to say a squared is equal to 3, b squared is equal to 1. Therefore, a is equal to the square root of 3, b is equal to 1, and c squared equals 3 minus 1. That's a squared minus b squared. So therefore, c squared equals 2, so c equals the square root of 2. OK, so again, now we look at our a squared, and we determine what variable is it under. A squared in this case is under the y. Now my major axis is going to be vertical. That means from the center, my vertices are going to be going up and down, and my co-vertices are going to be going left and right. So let's go ahead and plot the graph. All right, now we need to figure out what the center is. And a lot of times students get stuck again with that x squared because they're like, well, what is your h here, right? Because it's x minus h. Well, remember, or just realize that x squared is the same thing as x minus 0 squared. So therefore, h is going to equal 0. And k, you can see in this case, is the same thing as y minus k, right, squared. Well, this is y minus 2 squared. So it's y minus k, y minus 2. Y minus k, y minus 2. Therefore, k is equal to 2. So my center, which I'll write in red, h is 0, and k is positive 2. All right, so let's go and plot the information we have. We have a center at 0, positive 2. No, let's plot this in red. So that's my center. Again, remember that my major axis is vertical, minor axis is horizontal. So I'm just going to kind of, actually, you know what? I'll just do major. And I'll just, and then I'll just do here, minor axis. Actually, I want to just go all the way through. OK, so those are going to be the axes that my vertices and co-vertices, as well as foci, are going to lie on. So my major axis, my vertices, which is a distance of square root of 3. And again, square root of 3, you can just approximate, you can plug it in your calculator. But again, just realize like 1 squared is 1, 2 squared is 4. So the decimal is between 1 and 2, right? So it's going to be 1 point something. So like there's my vertice, and here's my vertice. Oh, wait a minute. That's square root of 3. Ooh, square root of 2 is going to be similar. It's just going to be a smaller decimal. And just to even approximate, let me just kind of show you what I mean by that. Square root of 3 is 1.73. Square root of 2 is 1.41. So square root of 3 is 1.73, approximately. And the square root of 2 is 1.41. Now, again, these aren't really that important because I'm not asking you to graph. But hopefully you just realize that the foci and the vertices are right next to it, really, really close to each other, and they're between 1 and 2. Whereas my co-vertices is a distance of 1, and they're going left and right. Okay? But again, the main purpose of this video is to find the co-vertices, foci, and center. The main thing, though, is graphing it, is just, again, realizing that it's a major axis, so therefore your vertices and your foci lie on your major axis that is vertical. So my vertices are going to remain with the same x-coordinate, which is 0. We're just going up or down. And they're going to go up or down 2 plus or minus a, which is square root of 3. My co-vertices are going up or down c. I'm sorry, my vertices, yeah, oh, I guess I did say co-vertices. OK, co-vertices are going left and right from the center. So if the center is at 0, we're going left 1 and right 1. The y-coordinate still remains the same. So that's going to be negative 1, 2, and positive 1, 2. My foci, I guess I did switch those around. My foci are also going up and down, but they're going up and down c. So the center, notice the foci still has an x-coordinate of 0. It's just going up or down from the center. So therefore, that's going to be, x-coordinate is still 0, and that's going to be 2, because that's where the center is. So from 2, we're going up square root of 2, excuse me, down square root of 2. So that's going to be plus or minus the square root of 2. OK, let's get into the next one. The next example is almost like exactly the same. All right, so the next example, we're going to do the exact same thing. But notice we don't have an a squared or a b squared. And what we need to do, but to counter that, notice that both of these equations are equal to 1, where these two equations are not equal to 1. So therefore, the first thing we need to do is divide so they are equal to 1. I guess I could have done that. OK, now just like distributive property, if I have a times b plus c, we know that's ab plus ac. Well, if I have b plus c divided by a, that's equal to b over a plus c over a. So if I'm dividing this expression, or these two terms separated by addition, that 18 needs to divide into both of them. So therefore, I'm actually left with an equation x minus 3 squared over 18 plus, that becomes 1/2, y plus 2 squared over 2, because 9 over 18 is 1/2, equals 1. OK, now I don't need all of this information anymore. All right, so let's go and figure out what a squared, b squared, and c squared are. A squared, remember, is always the larger of the two. So we have our two denominators. A squared has to be 18. So let's say a squared equals 18, and I'll say b squared is equal to 2. A squared, so a is equal to the square root of 18. To kind of make this video not so long, I'm just going to simplify this on my own. You can watch some other videos that I have, hopefully, to simplify radicals. So that becomes 3 squared of 2, whereas b equals the square root of 2. To find c squared, that is equal to a squared minus b squared, so that's going to be 18 minus 2. 18 minus 2 is 16. So c squared equals 16. That means c is equal to 4. Okay, so now again we need to determine, does it have a major axis that's horizontal or a major axis that's vertical? And again, that depends on where a squared is. If a squared is under x, you have a horizontal major axis. If a squared is under y, you have a vertical major axis. So you can see that my a squared of 18 is under the x. So therefore I have a major axis. So I'm going to plot the information again. And I'm going to plot the center. And I'm going to label that. Remember, it's always the opposite, as I kind of explained over here. So therefore, in my case, we have the center is at 3, -2. I'll plot that information over here. So I go 1, 2, 3, down 2. And then I'll label it so I don't forget. I'm also going to label the major and the minor axis so I don't forget. So I'll just put a nice little line here. And I'll say that's the major. And then I'll do a perpendicular line because the major and axis are perpendicular, and I'll label that the minor axis. Okay? And again, this is also helpful because now that we know A, all we need to do is move the distance or the value of A from the center along the major axis. Because the major axis, or sorry, the vertices as well as the foci lie on the major axis, and the co-vertices lie on the minor axis. All right, so we know A, which is the square root of 18, or simplified as 3 radical 2. Well, you know what? Yeah, let's go and say it. We know 4 squared is 16, 5 squared is 25, so it's going to be 4 point something. And again, I'm just sketching this so I kind of have an idea. So 1, 2, 3, 4, 5. Kind of get out there. So from here, so from the center, I'm going to go A to the right, A to the left. 1, 2, 3, 4, 4 point something. 1, 2, 3, 4, 4 point something. And I'll label those my 2 vertices. My foci also goes left and right. However, that goes left and right 4. So from my center, I'm going to go to the right 4. 1, 2, 3, 4. Foci. And to the left 4. 1, 2, 3, 4. And my co-vertices lie along my minor axis, which co-vertices is square root of 2, which is going to be 1.41, right, which I said. So I'm going to go kind of up 1, and I'm going to go down 1. And again, I'm not, you can connect these if you like to. That's not really the purpose of my video, though. I only really kind of graph so I have a visual way of writing down the information. So my center is at 3, -4. My vertices are going to be left and right from my x-coordinate, right? I have an x-coordinate of 3. I'm going to go to the right A, which is 3 radical 2, and I'm going to go to the left A. So basically, I'm going to take my x-coordinate, and I'm going to do plus or minus 3 radical 2, -2. For my foci, which also lie left or right, I'm going to go plus or minus 4. So I'm going to do 3 plus or minus 4, -2. Now, in this case, I didn't break that one down, but here you can obviously simplify this, right? So I'm assuming your teachers are not going to want to see this, nor do I want to see it. So break that up. What's 3 plus 4? 3 plus 4 is 7, and 3 minus 4 is -1. So I'll write that as 7, -2, and -1, -2. And then last but not least, is your co-vertices. Okay, and co-vertices is going to be a distance of b, which is square root of 2. Now that's going to be up or down, so the x-coordinate remains the same, right? But now we're going up or down, so we're going to be adding and subtracting square root of 2 to the y-coordinate, which is -2. So we do 3, -2 plus or minus square root of 2. Almost there. Almost there. All right, last example, we're going to do the exact same thing. It's not set equal to 1. To determine all of our information, we have to have our ellipse set equal to 1. So I'm going to divide by 36 on both sides. When I simplify this fraction, 18 over 36 is 1/2. 6 over 36 is 1/6. So therefore, I can rewrite this as x minus 1 squared over 2 and plus, oh, yeah, I guess I could, yeah, well. That's going to be y plus 3 squared equals 6 equals 1. Let's do a squared again. A squared equals, remember a squared is a larger number, which in this case is 6. So a squared equals 6. B squared equals 2. That means A equals the square root of 6, B equals the square root of 2, C equals 6 minus 2, or sorry, C squared. So therefore, C squared equals 4. So therefore, C equals 2. Right? We'll go ahead and plot the information. Plotting the information, my center is going to be at 1, comma, -3. So over 1, down 3. 1, 2, 3. I now have, that's my center. Since my a squared is under the y, that means I have a vertical major axis. See, this one had a major vertical axis. This one has a vertical. And then has a horizontal minor. Okay. Man, I hate the radicals, right? But it's OK. You know that 2 squared is 4, 3 squared is 9. So therefore, square root of 6 is going to be between 2 and 3. So again, we're going up and down for my vertices. So I'm going to go up to decimal. That's going to be my vertices. Down to decimal. That's my other vertice. My foci is going to be plus or minus 2. So from here, I'm going to go up 2 from my center and down 2. That's my foci. And then my co-vertices, which are going left and right, is going to be square root of 2, which again was 1.41. So that's going to go to the left and to the right. The main important thing I want you guys just to kind of understand is noticing the difference between when we have a major horizontal axis, a minor horizontal axis, and as well as understanding that along the major axis lies the foci and the vertices, lies the minor axis is the co-vertices. So now let's just go ahead and label everything. I just kind of did this problem and didn't really work my way through because I just want to kind of make the video move along a little bit. So my center in this case is going to be 1, comma, -3. 1, comma, -3, base of the opposites. My vertices, so from my centers at 1, comma, -3, my vertices are going up or down. So they're going up or down a value of A. So that means it's going to change the y coordinate because from your vertice you're going up, moving up, you're adding that to y and subtracting that from y. So my vertices are going up or down A. So that's going to be 1, comma, plus or minus the square root of 6. My foci are going up or down 2. Well, you can just add 2, right? Add 2 to -3 and subtract 2 to -3. So again, the x coordinate's not changing. It's just the y coordinate. So that's going to be 1, comma, -1, as well as 1, comma, -5. And then last but not least is the co-vertices. That's going left or right. So that means my x coordinate's going to change. And my x coordinate's going to change the value of b, which is square root of 2. So that's going to be 1 plus or minus the square root of 2, comma, -3. So there you go, ladies and gentlemen. That is how you determine the center, foci, vertices, as well as co-vertices of an ellipse. Thanks.